Welcome to E3 Wireworks, and we're going to show a little project today where we're going to link a fluid diagram into SolidWorks. So we're going to take a schematic diagram created inside E3 Wireworks from the fluid point of view and transfer the data into SolidWorks where we can carry out the routing. So we're going to insert a couple of sheets in our project. We've got an electric sheet and a hydraulic sheet because we can mix both of those schematics and intelligently link them. So from our database we can pull out various fluid type parts. We've got some tanks here with various inlets, and we're going to pull out from the database a valve, and this valve has got an electrical element to it as well as a fluid element to it. So we've got two sheets here, one hydraulic sheet at the top, electric sheet at the bottom, and as we go in and pull the part from the database, depending on which sheet is active will depend on what is presented to you to place. So drag it straight out onto the electric sheet, you get an electric valve symbol. If we go onto the hydraulic sheet, we're given the hydraulic valve symbol. So that's then available to link between the two systems. We can drag and move the parts around to link up with the ports on the actual tank there. And we're just going to add a few more parts from the database. So we'll add a T-junction and just rotate it with the hotkey R and place that below the valve. And then we'll go into the database and we're going to pull out a flange. So we'll just put the flange at the end of the T connection there. And then we're going to do some connecting up using the insert connection. Of course we can add hoses and tubes at this point if we want to, but we're just going to add a straight connection so that that connectivity can be taken through into SolidWorks. Okay, and just one final thing, we're going to add some reducers. So we'll take the reducers, so we're going to take a 5-inch pipe for example and reduce it down to 2 inches where it goes through the valve. So again we'll rotate that, place it in, and it inserts, makes and breaks that connection, and we'll do the same when it comes out of the tank and into the valve, and there we go. So that's our connectivity, very simple example. What we're going to do now is transfer that data into SolidWorks. So we're going to export the piping, which takes all of the equipment, the inliners and all of the connectivity, and we can now go into SolidWorks. So inside SolidWorks we need to have the routing module enabled, and we need to select the PNID, and we can go and browse for the information we just exported, import that data, and here we get the pipe processing of the tags, which is the pipe information, and this then loads into SolidWorks, and we're just going to set the minimum bend radius to 100 millimeters in the inside of that. We'll say OK to that for now, so that's processed the pipes, and we'll just cancel that, but it's added stubs to the points of connection that it's got that connection information from the schematic that we imported. So we've got a stub there on the flange, and we've got a couple of other stubs on the top of the two big tanks that we can see there. So the next thing we're going to do is insert our components from the equipment list. We select insert equipment, and it will then present you with each of the component parts that are available to place inside here. So we need to go and find, first of all we're going to find a reducer, so we take that reducer, and on the insertion point there it will automatically snap, and we can select the 5-inch to 2-inch reducer. OK that, and we need to cancel that because we want to go back in to do some sketching on the route. So cancel the auto route, and then on the sketch functionality we can then determine which direction that pipe is going to be routed. We'll just drag that along on the horizontal, and that converts that into a pipe and also adds the bend for us, making sure that we don't exceed any minimum bend radius. Next we're going to go back to insert some more components, and this time we're going to take the valve, and again there's an insertion point on there, so it automatically snaps onto that in line with the route, and it adds another route point at the opposite end, and we're going to add a T connection onto there. So we're going to spur off this. One was going to go down to the tank, one's going to go down to the flange. So we'll take the offered configuration there, and the final reducer we want to just rotate that using the tab key and pick the 5" to 2" there, so we've got that now forming part of our route. Okay, back into sketching, and we're just going to rotate that around a little bit. Right. Move that. Perhaps we want the T point to route outside of that stairwell, like so. So we just drag it and move it around, and it reroutes for you if you do this. Reconfigures the length of pipe required. Right, now we can just go back in and do some sketching. Take the pipe across here, and then take it down vertically, like so. And then we're just going to drag this up a little bit higher from the tank. Okay, that. So we've already inserted all of our equipment, so the next thing we're going to do is redo the process the pipe, and we can do that. We'll again read the information contained in the export from the XML file from E3 Wireworks, and there we've got the guidelines to show us, and we can actually convert that guideline into a route, and it automatically adds the bends for you and calculates the length between the bends. And on the final one, if it can't find a valid route, then it presents you with a possible solution, so you can either accept that or you can reroute the pipe in the way that you want it to go. So we've just accepted that, so that's completed that information there. We can just save that assembly, and it will then do checks to make sure there's no errors in that piping route, and we'll convert the pipes to equipment so that you can run off a bill of materials and calculate the length of pipe and segments required for this particular configuration. So that's everything from starting from the schematic, transferring that data into SolidWorks, doing the routing in SolidWorks, and finishing off the configuration there. So it makes good use of having that schematic front end to read in that data from the schematic connectivity.